technology. But then the second industrial revolution came in the 19th century towards the late this. That is what we call as automation. So we try to use automation because at that point of time, electricity was invented and the electrical motors, and then they have been used to do automation. And when we talk about automation, most of you will be thinking in terms of as Ford's automation of the mass production of Ford Model 3 car. But the actual automation started not with the cars but with meat packing industries. In United States, the meat production is a very big area. That is when they have to do the workers working in the meat packing industry will have to handle these animal carcasses for a heavy one. So for, that is where the first conveyor lines were invented and applied. Later on, that technology has been taken by automobiles to produce. Then the third industrial revolution came in the beginning of 1950s with the invention of computers. Computers have been utilized. For example, some of you must be familiar with computer numerical control. So the way computers have been used will be giving us the ideas in terms of how electronics and information technology could be utilized in manufacturing. And that is how the automation came and robots were invented, and robots and CNC machines, they all reduced the manpower used in actual manufacturing. Then that brings us to Industry 4.0. That 4.0 came in the circa 2000 onwards, essentially, because what happened is with the availability of internet and the information that we have, so artificial intelligence, machine learning, these are all the technologies that could be utilized, whereby we will be able to use. That is how the Industry 4.0 was coined. Essentially, what we will be doing is when we have, because in manufacturing, or for example, any process that will be requires people, processes, various systems, and various services that will have to be done. Now, all of them will be producing a large amount of data, and what we need to do is use all that data in real time so as to see if any correction has to be done to the system, it will be done automatically rather than taking an action later. So, so this was German government initiative started in 2011, and now it is being used, but it is at a early stage now. There are some industries which have been extensively using, and some. So conceptually, if you want to talk about the fourth industrial revolution, you can say it is the sharing of information through the internet between manufacturers, suppliers, and customers. I will show you an example a little later. The main benefits that you will get with the adoption of Industry 4.0 is operational excellence. That means the productivity will be improved and the downtime will be reduced, and the resources that you have will be able to use optimally, and the quality and consistency that you can achieve will be higher. Now these are all the main advantages. Now, all these advantages will be derived essentially by data-driven decision making. So, what we will be doing is data to be collected continuously from the system. Data will be collected continuously, and then the data will be analyzed continuously using the big data analytics, so that that raw data will be converted into an insight that will be used to take the informed decision. Either you can take a decision automatically by the system itself instead of any human intervention, or it can be done by a human intervention. Depends upon the situation. Now, this gives you the agility and flexibility. So, mass customization is possible. Now, the supply chain optimization, that means when you have supply chain, a long supply chain across a number of places, then you can create the logistics in such a way that you will be able to handle them automatically, so that any disturbance when it comes will be automatically taken care of. And because of this, you will be able to take any product faster to the market. And the benefit for the people who are working on site will be enhanced safety, and then the value of contribution by the humans in the system will be much higher than what is possible. So improved working environment, enhanced safety, and high value work. These are all that will be possible. Now, which are the enabling technologies for the Industry 4.0? Advanced robotics, Internet of Things, we will talk about that, and big data, artificial intelligence and machine learning, augmented reality, horizontal and vertical integration and simulation, cloud computing, additive manufacturing. These are all and cyber security. Now, these are all the things that will have to be are coming, and because they are available today, that we are able to talk about Industry 4.0. Now, advanced robotics. What we mean is you're all familiar with normal robots, but robots will not be working in isolation. People will have to work together with it. So a collaborative robot is essentially a robot designed to work in a common area with the production operators. So then it integrates the safety functions needed for direct interaction with a human being in a defined cooperative. So they are normally called as cobots. In fact, you can see the way the robots are increasing in use. So today, for example, Amazon warehouses have been using a 1 million robots. And you can see here the way they are progressing from, let us say, 2018, which is relatively about 100,000, to 1 million in the last 5 years' time. So that is the amount of progress. And here is a small video that is available on YouTube. You can take note of it, and you can see it's a small one. It gives you.
Have you ever wondered how humans and robots work together at Amazon? From the moment a product enters our fulfillment center until it heads out to a customer, Amazon technology helps our associates in so many incredible ways.
Amazon introduced our driving and robots in 2012, which led to 300,000 new time jobs.
These are the snow stations. Use artificial intelligence and computer vision.
Yeah, pretty cool.
This is the pallet manager. It uses computer vision to stack books of products.
There's so much cool technology that goes into this.
Oh yeah? Like what?
Well, like 2D imaging, a laser sensor, I'm on performance at 165 kilograms of capacity.
Wow, amazing.
Our tech vest help communicate with the robots to keep us safe while working on the field.
I think your tech vest could use a little more tech.
Thanks, but I think my vest already has everything it needs.
Incredible.
I know, right?
Amazon's human and robotic powers combined, we are building the future of technology together.
Now, the main unit of all this is big data analytics. Big data refers to the large amount of data that is generated from any number of items that are present in the connected systems. And then what you will be doing is you will utilize artificial intelligence and machine learning to make the data generate insights, and then from that insight you will be able to take automatic decision making, optimize the production schedules, and enable predict maintenance, whatever anticipating the equipment failures which would actually occurs. That is what normally is done. And cloud computing provides a massive on-demand IT resources, for example, in terms of data storage and processing power needed to store and analyze the large amount of data that is generated by industrial IoT devices that are connected to all the equipment that is in operation. And now, when you say cloud computing, the data has to go to the cloud and then come back. So it may be some time consuming. So in such cases where you cannot afford the time, then edge computing will be used. Edge computing actually processes data closer to the sources, so that that will reduce latency for real-time decision making and control. Augmented reality superimposes digital information onto a physical view, so that you can help. For example, if a maintenance person is working on an equipment, the actual information related to the maintenance can be available to him on the augmented data set, that is in the form of goggles that he will be wearing. Cyber security, because the data is going into the cloud, so we need to have security in all ways. So if you have to implement SAP 4.0, what are the steps that you will have to do? First step is to understand your system. So whatever system that you are going to work on, you have to collect data. First step is towards the digital transformation is to collect data from all your equipment, because that will give you an idea about how your system is working. And once you have collected the data will be used for digital modeling. So the second step is to develop the performance models for your equipment. And then the third will be predicting the performance. So once you create using artificial intelligence and machine learning, you have created an mathematical model for your equipment. So what you would like to do is you put the current active parameters into the model and predict the performance of the model based on whatever parameters that you are currently working on. So if the performance is satisfactory, you can leave the parameters as it is. But if the parameters are not, the predicted performance is not happy, you can adjust the parameters so that your output will be coming. And then the process will be continuing, because this is a continuous process. So with the new parameters, new data will come, new model will get updated, and this continuously happens, so that you will have a self-adjusting system that will be operational. Now, if you remember, if you see the communication technologies, trying to reach 100 million customers in any of the communication technologies. The first communication technology is, of course, telephone, invented back in 1876, and it took 75 years to reach 100 million customers. And in 1989, that's 100 years later, when the internet was invented, it just took 70 years to get 100 million customers. And in Facebook in 2004, it took only 4 years to get 100 million. And Instagram, just 2 years. And the game Pokemon Go took just 1 month to get 100 million customers. So the way the information technology is moving very fast. In fact, if you see some of the technologies, for example, ChatGPT, it took only 2 months to reach 100 million customers. And TikTok only 9 months. Instagram over 2.5%. So, you look at 1 million users, you can see ChatGPT just took only 5 days. That is so fast the information is moving. And the projects that you probably many of you must be familiar with. It took only 1 hour to get 1 million customers. That is how information is moving very, very fast. And as a result of the changes that are taking place in information technologies, what is happening is the type of job roles that people are required is changing. In 2022, this is what the top 10 job roles are. Data analyst, artificial intelligence and machine learning, big data, digital marketing, process automation, business development. So these are the things. But by the time 2025 came, things have changed again. Now, number one is artificial intelligence and machine learning. That is data scientist. That is the number one. Cyber security is number two. And then and healthcare registered nurses, software developer for renewable energy engineers because of the sustainability, project managers, cloud architect. So these are the current top 10 roles that have large amount of demand. So obviously you will have to work or learn in those areas. And similarly, some of the jobs that either gone or decreasing in demand. In 22 is data entry clerk, administrative, accounting, accountants, assembly, workers, business services, etc. But by the time 2025 came, things have really changed. Administrative and executive assistants are gone. Data entry and record officers, telemarketers, bank tellers, because most of them have been automated using AI. Bank tellers, financial credit analysts, etc. etc. So now let's look at the thing, the backbone of the industry 4.0 is IoT, Internet of Things. What is Internet of Things? Now, this is essentially an identifier that is attached to the equipment that you are going to use. It could be in the form of an RFID, it could be using the Bluetooth, it could use Wi-Fi, or it can use a QR code or a barcode. The way the information is transmitted, communicated. So barcode is the lowest form, QR code slightly better, but those are manual. Whereas RFID, Bluetooth, and Wi-Fi will be the ones that are most generally used. And when an equipment that you are going to use, if it is attached with an IoT will be able to transfer all the information from the equipment to the computers. Okay. So therefore, the equipment in the real world will be linked automatically to the online world. That's the idea of putting an IoT. IoT essentially is a transmission medium. Now, how do we use IoT in a system? This is what IoT architecture will look like. So what you are seeing is, this is where we have our equipment. And then they all generate large amount of data. That data will have to go through gateway. So this is what we call it a thing. Thing is an object that is equipped with sensors that gather data which will be transferred over a network. And then there will also be an actuators. Actuator will allow things to act. That means you generate the data, send that information, and based on that, if you need to take an action, that actuator will be working. Sensor will be generating the data, actuator will be correct as required. So IoT is the starting point. Then next, when the data that you are generating here will go through a gateway, that is the data goes from the IoTs to the cloud through these gateways. And then there will be the cloud gateway. This is the gateway at the system, and this is the cloud gateway that facilitates essentially data compression and secure data transmission between field to the cloud. From there, there will be data that will be stored here, which can be utilized subsequently. Then this data lake is where the data that is originally generated in its original format will be stored. Now this is the original data. From here, the next it goes to big data warehouse. That is where this information that is present in its original form here will be filtered and pre-processed in a way so that meaningful information or meaningful insight can be obtained from here. Okay, that is where we will be getting machine learning. So data analytics is where we have the data. From the data, we will be using data analytics to create machine learning. That means essentially we are forming a mathematical model for the system that is generating this data. And from that mathematical model, will actually create. So that means you create the model, you run the model, and you get the performance and compare the performance with what you wanted to get. And if there is any correction to be done, that correction can be conveyed to supervisor in the form of a web application, or you have an app in your smartphone where you will be able to get. So if an action is to be taken, that will be taken here. That will be essentially a user application. Now let us see how we can use this as a simple application of dairy farm. So dairy farm is essentially a factory where you have workstations that are cows, and you will be feeding whatever feed to be given to the cows, and they will produce milk. So this is the input and this is the output that is coming. So a smart dairy farm is a simple manufacturing environment with cows and feed coming in one end and milk products coming out the other. So the immediate problem for the farmer is replacing or adding to his production capacity. That means he has to increase the number of cows that he has. That is how he will be able to get. Now, the way that is done in any regular dairy farm is there will be artificial insemination will be done. Dairy cattle are largely produced by artificial insemination, and we will be doing this long enough so that we can get up to 70% conception rate, but only if the procedure occurs when the cow is in what is called as estrus, a recurring period of sexual receptivity and fertility in many female mammals. Now, if you have only one or two cows, it is easy to do. But if you have hundreds of cows in a normal dairy farm, it's almost impossible to find out which cow is in estrus. So, very difficult for the farmer, though he had the experience based intuition to find out when it is likely to be. But there statistically only 55% of the time they are able to do. So as a result, the actual output that they able to get is 39% pregnancy, which is way lower. So what they have done is in Japan, Fujitsu has been given the responsibility to come up with a system how smart dairy farm can be produced. So what they were able to do is they made 95% accurate in the pregnancy rate to so that they could get an improvement from the 35% to 67%. So 70% improvement in performance. Now the question is, how do you detect stress? That is because the cow is in stress once in every 21 days. And that stress lasts only about 12 to 18 hours. And just to make it that more difficult, it happens between 10 p.m. and 8 a.m. Probably that is the time when the farmer is sleeping. So, how I'll show you a small. So here, what they have done is they have attached a pedometer to the cow. You can see here that is the pedometer, and the number of steps taken per hour have been obtained from that. So what you are seeing this green is the regular cow characteristic based on time during the daytime. Now this orange one that you are seeing here is actually the one when the cow is in stress. Now if you see here between this and this difference is not that much, but as you go, you can see sudden jump. So this is the time the stress is detected. The system will automatically detect. Then what you will have to do is the optimum point where that artificial insemination has to be done is 16 hours later to that stress detection. Either you can do this on this side or on this side. So what they have done noticed is if you carry out the insemination 3 hours before that optimum value, you are likely to get a female offspring, that is a cow. If you do it 3 hours after that, probability is male. So obviously you are interested in more cow, therefore you should be able to carry out this. So this information has to be done. So this is the way the cow is behaving. And when it comes, when this is lower, then it comes back to normal. So then there is nothing that you can really do. So the optimum time for artificial insemination is 16 hours later after identifying the stress. And the very added bonus is that AI performed the first 2 hours of the window has a much higher probability of producing the female. This is what the system that they had. Cow with a pedometer, and there is a dipole antenna, a receiver, and then a router, and that router actually communicates to the base station over the internet that goes into the internet, and from the internet it goes to the cloud center in Microsoft Azure database. That is where the analytics will be carried out. And once they have done, the communication will go back through the internet to the office either to the computer or to the communication device, for example, a mobile of the supervisor. So that will give you good cow in the nestress when the actual insemination has to be done. So in field testing for a group of 11 dairy farms that they have taken, the farmers achieved an annual increase in the size of the herd compared to the historical methods is upwards of 31%. Okay. If you are farmer, that is all you would like to have. Now, how did the Fujitsu scientists come up to this? They must have struggled to come up with this technology. First of all, as a data scientist, what are the biological factors that will be needed, that will have to be identified? So that is what. In fact, there is a very nice video available in YouTube. I will not run that. This is a much longer, about 8 minutes. Please go through it. It will give you a very nice idea about how IoT can be applied. Another that we normally like to have is digital twin. That's what we will use in smart manufacturing. What is a digital twin? Digital twin is a dynamic virtual replica of a physical object, system, or a process that is continuously updated. Essentially, for example, let us say you have a CNC machining center. A digital twin is essentially a mathematical model of that CNC machining center. So whatever that you are doing physically can be done uh, electronically on the digital twin. So what you will be doing is you will be carrying out simulation on the digital twin, and when it is successful, you will implement a physical system. That is what a digital twin essentially helps you with. So core components, a physical twin is a real world object, system or process. It is equipped with IoT, sensors and data sources. So this is the physical system. And a digital twin essentially is a software based manufacturing model. So the connection will be data flow between physical to digital, digital to physical. Both will be done. So when you get a sensor data, you will develop the mathematical model, run the model, get the output, optimize the performance, and put that data back to the physical system. The key benefits essentially predicting, forecasting the future performance, optimization, what if scenarios you can apply, remote monitoring, reducing cost and risk. In fact, they are applied in all fields: manufacturing, aerospace and defense, smart cities, healthcare, automotive, as well as construction. Now, before I close, I just want to give one example of product quality control based on condition monitoring. Quality control based on inspecting the work in progress provides you more accurate results. It helps to uncover their certain because so it can be based on monitoring the condition and calibration of machine. Helps to detect the bottlenecks in the manufacturing operations, identify badly tuned and underperforming machines, timely prevent machine damages. Now let me show you an example. So if you have an equipment that is being done, so you will have the sensors that are present. So they will be parts that are in progress coming through. So the robot will be doing the quality testing, and that quality testing data will be going into the quality monitoring system, identifies if something is wrong, something is happening, then it will can identify what action needs to be taken. what correction need to be done, either the machine parameters, tool parameters, or whatever that will have to be done. And then that will be communicated to the supervisor who can really take the action. For example, the Maastricht Mill, a Dutch paper producing company, has actually used IoT to produce the quality of paper. Similarly, BMW actually uses smart maintenance using this. This is for the production of their electric vehicles and train lines. They have done, and they were able to reduce uh, about 500 minutes of actual vehicle assembly time, but it essentially when they have to stop because of maintenance issues that they were able to reduce it. So in this 4.0 helps manufacturing enterprises to maximize the productivity through maintaining production uptime, reducing costs, eliminating waste. Now leveraging the industry 4.0 data, the manufacturers get a better understanding of the manufacturing and supply chain processes, improve demand forecasting, achieve cost savings. However, the main problem is the actual scale and complexity is very high. And therefore, you will have to see what are the segments that you can actually apply, where you can apply. So it's a process that it is going on. Thank you. And if you have any questions, I'm ready to answer.
Thank you so much, sir, for the brilliant lecture. Now I want to invite the audience. If you have any question, you can ask the Professor Pinto.
Sorry, I had to go a little faster because of the short time that you have. Probably your lunch time is approaching.
No, sir. After this also we are having one more session. Anyway, any questions from the audience, please? No, sir. Okay, sir. Sir,
Okay, thank you very much.
Thank you, sir. And now we shall be moving for the next session. Our next session, that is the joint declaration, and after that, prize distribution and valedictory session that will be completed. Professor Das, if you may please. Yes.